Hello everyone, welcome to our channel Code with Sunny, and in this video I am going to talk about the problems of Codeforces round 719 division 3. The very first problem, problem A, do not to be distracted. Okay, so the problem statement seems to be very much longer, so I'm not just talking about this entire problem statement. I recommend rather than to you to read this problem. Okay, so I'm just talking about the overview of this problem. Okay, so you can easily see if we would have been given a string s. Okay, I will talk about this string. Something string is will be given to us, and we need to check it out that if we have some string, like let's say we have the characters like A, B, C, and then after that, if this string contains some character that is now repeated again, you can easily see this B has already occurred over this one. Okay, so if some character has been repeated again rather than in continuous form, like I just want to say that if we have the characters like A, and then then the character changes like it becomes B, and then we found again the same character like A, then only I'm just going to report that this operation is going to be like suspicious to the person like the teacher. Oh, okay, so the teacher is going to like found the sequence is going to be like suspicious. Like if we have some certain sequence of same characters and that character is again found later on, then the teacher is going to find out the sequence is said to be suspicious. Okay, so we are just going to find it out whether the teacher is going to find that sequence is going to be suspicious or not, and we are going to print yes if the teacher cannot be suspicious, otherwise no. Okay, so let's understand this with a small example. Like consider this BAB. You can see if B is present, now the character changes, and again this B is found now, so this is going to suspicious sequence, and we have the same characters A. Now the character changes, it becomes BB. Now the character changes CC and DD and EE. Then you can see B is found, which is already found over the previous characters. Now we are going to report this as a suspicious sequence. You can easily see A and this Z. Now the character changes again to the A, and which is already found over the previous sequence of the characters. We are going to report here as suspicious sequence. Okay, so we are going to basically check this condition. So I'm just talking about the code now. You can easily see I've just taken a vector. I'm just going to zoom it out. A vector of characters, and first character is pushed. Now start iterating to the characters up to the n size, and if my adjacent characters are not equal, push the character and just take a set over here and push the first character to the set. Note that this for loop is going to just take the distinct values in the sequence. Like if we have the characters like this one, okay, and this A 4 times A, then Z, then this 4 times or this 5 times A, this will push the sequence of characters in the vector like A, then Z, then A. Okay, and this is going to basically push the distinct sequence of characters, like this D should be pushed, then this B, then only this C, then B, then E, and then Z. Okay, so this vector is going to store the distinct characters present in the sequence, and this set is going to check the condition. First element is pushed, and I'm just checking it out the condition. Okay, up to this entire vector V. Okay, and if at any position, if I'm going to find out the same character of this vector already occurred, that is already present in the set, just print no, denoting that this is going to be like teacher can be suspicious, and otherwise print yes. That if you are not going to enter into this condition for any of the I, for every I belongs to 1 0 to vector dot size -1, we are going to like print yes, otherwise for any I, if this condition holds true, just print no. So this is about this problem A. So let's talk about this problem B now. Okay, I'm just going to erase this stuff now. Okay, so this is going to be erased. Now let's talk about this problem B. Now in this problem you can easily see we have a positive integer n, and it is called as ordinary if the decimal notation of all the digits are going to be same. And here are the some examples of ordinary numbers. And for a given number n, we need to find the number of ordinary numbers among the numbers 1 to n. T test cases will be given, n varies up to 10 power 9. For each test case we need to output the number of ordinary numbers among numbers 1 to n. Okay, let's try to understand this with the help of example. Like ordinary numbers are like 1, 2, 3, 4 because you can easily say up to 9. Here are only one digit is present, and our if ordinary number definition is like all the digits should be same, and you can see only one digit is present, so these are the ordinary numbers. And let's talk about two digit numbers, and if all the digits should be same, so it should be like 1 1, 2 2, 3 3, and at up to so on it goes up to like 9 9. These are the ordinary two digit numbers. And let's talk about three digit numbers. It will be like again 1 1 1, 2 2 2, and up to it goes up to like 9 9 9. Now the main thing is like if we have been given some number n, and we need to find it out what could be like the total number of ordinary numbers which is going to be like less than or equal to this number n and should be like greater than or equal to this number 1. Okay, so how we are going to do that? You can easily see if we have been given the number n, and let us say x is the number of digits present in its that is number of digits present in this number n. Like if we have been given n as like 2, 3, 4, 5, so you can easily see there are 4 digits present in this number. So I'm just talking about x. Let's say x is going to denote the number of digits present in this number n. So you can easily see x minus 1 should be like all the digits whose okay, so I'm just talking about all the numbers whose digits is going to be like less than or equal to the x minus 1. X minus 1 is going to be like number of digits minus 1 of the original number. So x minus 1 into 9 should be included in our answer. And the reason behind this is for every digit you can see single digit has 9 ordinary numbers, double digit has also 9 ordinary numbers, triple digit has also 9 ordinary numbers. So if we have been given the n and x denotes the number of digits in n, then x minus 1, all the numbers that can be formed having digits x minus 1 or less than equal to x minus 1 will always be less than or equal to n. So number of ordinary numbers should be like x minus 1 into 9. And can the answer be included for the x digits or not? Okay, so let's talk about x digits or not. You can easily see if we have been given 2 3 4 5, and I am talking about only x digit ordinary numbers, so 1 1 1 1 should be included in our answer. So my answer should be incremented by 1. And if 2 2 2 2 should be included in our answer or not, you can easily see this number is like less than this number, and this all the digits are going to be same, so this is going to be an ordinary number. Okay, so this 3 3 3 3 is should be included or not. You can easily see this is going to be like greater than this, and so this should not be included in our answer. On all the further numbers having the same digits should also not be included in our answer, because these numbers would become the larger than this number n. Okay, so in general I can also write that if we just try to fill up all the numbers, fill up all the digits whose value is going to be like equal to the first digit, that is this one. So I'm just talking about let's say a number n dash. It should be like 2 2 2 2, or like 4 digit, no? Okay, so I will stop it over here. So if we try to find another number n dash whose all digits are is exactly equal to the very first digit, that is this one. And let us compare this n dash and this n. Okay, so if we compare this n dash and n, so I'm just writing down two conditions. If n dash is going to be like greater than or equal to this n, okay, so I'm just including some keys like, okay, so I'm not writing this down, I will write another thing. Like if n is going to be like greater than or equal to this n dash, I will include all those numbers. I will increment my answer with the value equal to the very first digit, that is with the value very first equal to 2 over here. Otherwise if n is going to be like my number is going to be like less than this n dash, I will just add the value equal to this digit, first digit minus 1. And let us take understand this with the help of example. Suppose we have the number like 2145. this is obviously less than 2, 2, 2 and 2. This is obviously less than this one. Okay, so if we find out this number, you can easily see my ordinary numbers will stop up to here. That is 1, 1, 1, 1. So if I will try to include this as the ordinary number into our answer, this should not be included because this number would become less than this number. That is, sorry, greater than this number. So this should not be included. So in general, I'm just trying to say if this is n dash and my n is this one, I will just try to form a new number n dash whose every digit is exactly equal to the very first digit of this number. Okay, and let us compare n dash and n. And if n dash is going to be like greater than n, or okay, so I will not consider this one. If my actual number, yeah, this number is going to be like less than n dash, I will just include my answer like d minus 1. Otherwise, I will include my answer as only d. That is, if my n is going to be like greater than or equal to this n dash, I will include only d. Okay, otherwise include d minus 1 as into my answer. That is, increment my value by d minus 1. And the reason behind this, I will include all the numbers like 1, 1, 1, 1, 2, 2, 2, 2, up to the so on up to the very first digit count. Okay, where d is going to be like the very first digit of this number n. Okay, so let us try to understand this one with the help of coding part also. The string is going to store the string format of this number n, and we have str also, and try to convert all this, try to form a new number n dash. Okay, with every digit same and digit value exactly equal to the very first digit of this number n. Okay, so you can easily see my answer will be incremented by length minus 1 into n for all the numbers whose digit is going to be like strictly less than the number of digits present in this number n, and I will also increment my answer for by the very first digit d, which should be like s of 0 minus 0. And if this condition holds, that is my new string formed n dash is going to be like strictly greater than this one, I should have to decrement my answer, okay, by 1. Okay, you can easily see this condition. That is, this n dash is going to be like strictly greater than this n. I should have to decrement my answer. Finally, print the answer. This is the solution for the C part. Okay, so now I'm going to discuss what the solution of this C part of this contest. Okay, so I'm just coming over this non-adjacent matrix. Okay, so I'm just talking about this. We consider the numbers a and b as adjacent if they differ by exactly this amount. Absolute value of a minus b as 1. We have been given a square matrix n into n, and if they have a common side only when this condition holds. And for every given n, construct a square matrix of size n into n, and every integer should lie up to 1 to n square and occurs in this matrix exactly one time. And for every adjacent cell, then the numbers written in them must not be adjacent. Test case 100 and n is going to be like 100. For each test case, I have to output minus 1 if there doesn't exist a suitable matrix, otherwise the required matrix. Okay, so let us try to understand this problem with the help of example. Like if n is going to be like 1, you can always form a 1 matrix, and this is going to be our answer. Like if n is going to be like 2, I will just explain this like always try to approach these type of problems with the help of base case examples. Like I've taken n as 1 and take n as 2, it should be like you have to fill 4 elements. Like elements size should be like 1, 2, 3, 4, and elements cell difference, like if we consider these 4 cells, and it should be like this cell, if we spot this cell, then okay, so I will just make some larger matrix. So if this is the cell I'm talking about, then let's say it has a value of x and y and z, then mod of x minus y should be equal to, like it should not be equal to 1, and mod of x minus z should not be equal to 1. And let's say it has a w, then y and w should also satisfy this relation, yx also, and similarly zw zx also. Okay, so if n is going to be like 2, I should have to fill up the matrix with these values. So it doesn't matter how like which numbers you fill in this matrix, you will always find the adjacent cell difference should be 1 for any one of the cells, like at least one cell. So let us try to fill like 1, 2, 3 and 4. You can see this absolute value, this absolute value is coming out to be 2, this absolute value is coming out to be 3, but this absolute value is coming out to be 1. And according to the condition of this non-adjacent matrix problem, then the numbers written in them must not be adjacent, like they do not differ by 1. Okay, so this is going to be wrong. So for any arrangement of the numbers for n equal to 2, I will have the answer as -1, denoting that no suitable matrix is going to exist. Okay, now let's talk about n equal to 3 and for greater n. Now I'm just going to claim that my answer will always exist. And why I'm going to do that? You can easily see if I will try to build a 3 into 3 square matrix. So the matrix would be like this one. Okay, so let us try to number these cells with the like even and odd. If I will have like 1, 2, 3 based indexing of the columns, and this is for rows, and if we try to sum up the index number of this row and index number of this column, so this column, and that is this first row and first column is going to be like even, this odd, then even, odd, even and odd, even, then odd, then even. Okay, so my approach would be like start filling the numbers. Note that I will have to fill the numbers from 1 to this n square, and here n is going to be like 3, so I have to fill the numbers from 1 to 9. So I will start filling the first even positions, or you can also fill the odd positions. It doesn't matter. Let's say I will have to fill up for the odd positions. I will fill this 1, then I will fill this 2, then 3, and then 4. So you can easily see if I will fill up the odd positions, you can easily see they are going to be like alternate. Like odd positions had adjacent. So I'm going to mark it with another color. What are the adjacent cells of this odd positions? Even positions, even positions, even positions. So if I will just put the numbers starting from 1, so 1, 2, 3, 4 for the odd positions, you can easily see. So for every even position, it is guaranteed that the adjacent value, that is the difference absolute value for even cell and odd cell, is not going to be like 1. Okay, let's try to fill up that. So I'm just erasing this one. Okay, so 1, 2, 3, 4 is filled. Now I have to try to fill 5, then 6, then 7, then 8 over here, and then 9 over here. So my matrix would look like this one: 5, 1, 6, 2, 7, 3, and 8, 4. Okay, I'm just trying to write down clearly: 8, 4, 9. So if you find the adjacent absolute value of any of the adjacent cell, you will find that it is not equal to 1. That is, I'm talking about any of the adjacent cells. And similarly, you can also do that for n equal to 4 also. That is, first put the values starting from 1 to up to so on, starting from 1 to like n square. First even value, even positions or odd positions, then try to fill up for the alternate one. Okay, and you will always find the absolute value of the adjacent cells is not going to be equal, because in a matrix you can easily see the odd positions and even positions are going to alternate. That is, even position has a adjacent cell of odd positions. So if you try to fill up some value for the even position, and then if you complete the values for all the even position, then come up for the odd values, it is obvious that they are not going to coincide with absolute value equal to 1. Okay, so let's try to implement this in the coding part. You can see here it is an accepted code. So n is 1, then print 1. Finish 2, our answer is like -1. We cannot find any suitable arrangement of values, okay, from 1 to 2 square. Now start with x equal to 1, and here a matrix is going to be like a 2D array, and start from 1 to n, and for j from 1 to n also. And if it is going to be odd, uh, store the value of x and increment the x. And similarly, first I'm done for all the odd positions, you can easily see. Then I'm doing for the even position, and it is guaranteed that the adjacent cell absolute value is not going to be coincided with the value equal to 1. Then try to fill up for the even positions of this matrix. That is, sum I plus j mod 2 exactly has the parity equal to 0. Print the, that is, store the value of x and increment x. Finally print the answer of this matrix. Okay, so it will give you an AC code. Okay, so if you have any doubts, do let me know in the comment section of the video, and I will ask the viewers to like this video, share this video, and do subscribe to our YouTube channel for latest updates. Thank you for watching this video.